Okay, this is precalc 1.5, last day of 1.5. We're going to talk about piecewise functions. Guys, piecewise functions are functions. They're just made up of other functions. Obviously, we're calling it a function, so therefore it will pass the vertical line test. You're not going to have parts that, an x value goes to two different y values, and they're usually made up in a system like we have here, where we have f(x) is equal to different equations that have domains. And those domains are different from each other so that there's no overlap. And so, this is what we're going to do. We're going to graph this. And to graph this, you need to do these 4 steps. The first one is I want you to find and graph the domain changes. Now, if there's only 2 equations, you can obviously see down in our problem here that 2 is where the domain changes from one to the other. That means something happens at 2. That's the only one. If there happened to be a third equation, you would have to have another domain change. It would have to start and stop somewhere else. Therefore, you would have 2 domain changes that you would have to graph, and your graph would be cut into 3 different areas. Because in step 2 it says make a t-chart for each side of the domain change. Which means if there's 1 domain change, your graph's cut in 2. If there are 2 domain changes, your graph is cut into 3 parts. And there would be 5 t-charts. So it's always 1 more t-chart than it is domain changes. We're going to see that as we go through in our problem here. And then I need you to identify which equation goes to which domain, the top one on the left or the right side. And then you can fill in the t-charts that you created, starting at the domain change. That means in our problem, we're going to put 2 in both of those t-charts, and I'll explain why in a second. And then, once you have your t-charts filled in, you just start plotting your points out, starting at the domain change, walking away, and then connect them. This would be, I think, the most efficient way to graph a piecewise function. Now, several years ago, when I was in your type of seats, I learned that what you do is you graph both of those equations on the same graph, and then you go back and erase half of it. I think that's a little tough. It's kind of decide, okay, where do I erase, where do I stop erasing, which one do I keep, which one do I not keep. I just think it's just too much work. I think if you understand that your domain starts and stops, as in a graph will run to one part of that line and someone else will grab it and go, like pass the baton, it'll make it a lot easier. So, looking at our problem there, I got x squared minus 4 if x is greater than 2, and 3x plus 5 if x is less than or equal to 2. I think everybody should be able to see that I have a domain change where? Right, the domain change at 2. So, this is what I propose. I propose that you make a graph and you put that on there. So what we have here now is a graph, and I'm going to go through in red here. I'm going to put it at x equals 2. That's not 2. At x equals 2, I'm trying to put a dotted line. The dotted lines, remember, when we graph things, aren't really there. It's going to affect my graph, though. That's our domain change. Do you see that the red line cuts it into a left side and a right side? So now, what we need to do is make t-charts. In step 3, actually step 2, you make a t-chart, one for each side of that domain change. And in step 3 or 4, I need to identify and then start to fill it in. But before I even start to fill it in, the domain change is at 2, so guess what? I'm going to put 2 as my first point in each one. Basically, I'm going to set it up so that both sides start on that line, and then they're going to run away from each other. That's basically what it make it out to be, is that way you can't ever cross. You'll never cross the line, because if you both start there and walk away, you can't join back up, because it's a function. And so now, once we have this style set up, we need to look at these equations and say, okay, which one of these is on the left and which one's on the right? X squared minus 2. It says where x is greater than 2. What side is greater than 2? That's the right side. So the right's the top one. The bottom one must be left because it's less than or equal to 2. Wait a minute. One of these is greater than. The other one is less than or equal to. So what does that mean? At 2, which one's included, which one's not? The right one included? No, the left one is. So this is what I propose here. I propose on the left, you put a solid dot at 2, or for point 2. On the right, I'm going to go over there, and I'm going to put a small open circle. Those are the only ones that you have to worry about open or closed. Everything else is closed because everywhere else on that particular graph is included. And then this is what I do. Again, like I said before, I'm going to walk away from the line. So if I start at the line at 2 and I go to the left, the next one is 1 and then 0. So guess what? I'm going to put 1 and 0 into my t-chart. Going in the other direction, I'm going to put 3 and 4. And now all I do is fill it in with the right equation. Take a look at the right side. The right side is the top equation. 2 squared minus 4. 3 squared 9 minus 4. 4 squared minus 4. 12. Everybody got those? Everybody understand that all I did was place them into the top equation because that's where the domain says I should. On the bottom, 2 times 3 plus 5. 1 times 3 plus 5. 0 times 3 plus 5. 5. Notice why I made my graph a little bit taller? I kind of knew there was values that are a little bit taller in this one. So guess what? Just graph them. I'm going to start with the left t-chart. 2, 11. That's 5, 6, 10. So that's 10. So 2, 11. And it's a closed dot. Yes? Okay. 1, 8. Closed dot. 0, 5. Closed dot because they're all closed dots. Wait a minute. The left-hand equation there, the 3x plus 5, what is that? What kind of equation should that be? Or is it? Is it a square root? Is it a cubic? What kind of graph is that?
Square root.
It's not a square root. 3x plus 5? You guys are scaring me. 3x plus 5. It forms a... It's a line. So guess what? If I connect those 3 points, it should form a line. Mine doesn't look the best. But I'm going to start at the line, the dotted line, and work my way away. I see why. Do you guys see that I made that point at 1, 7? Should have been a little higher. Ooh, wrong. Back up. That's a little better, I guess. Now, the right-hand side, The top equation is x squared minus 4. That's a what? It's a parabola. It's U-shaped. Shouldn't be straight. Okay. 2, 0. Wait a minute. But at 2, 0, the point is open. Because if it was closed, I would have a dot closed above and below, and then would that pass the vertical line test? No. So therefore I can't do that. Next. 3, 5. And then 4, 12. Nope. Why are they not open? Basically, ask yourself, does 3 satisfy x greater than 2?
Interruption at the end of 7th hour.
This is a piecewise function because the graph is a function here. It's still a function there and goes up. Wait a minute. Is that continuous or discontinuous, guys? At 2. It's discontinuous at 2. By what kind? Jump. Okay, guys, that's a piecewise function. If you guys can handle that, you guys should be able to handle multiple parts or any type of functions in there. Your homework is going to be page 52, just 32 through 34. Have a great day.